Hello, hello. Nice to meet everyone. I'm George Yates, and this is not Adrian Lee. I'll let you introduce yourself.
Hi everyone, I'm Prashant. I'm part of the field CTO team at Snowflake. I'm basically filling in for Adrian, who was the original speaker for this session.
And so just to kind of set an agenda, what I wanted to do is first give an intro to, or Prashant will give an intro to Snowpark Container Services and Airflow. And then I'm going to talk about why Airflow, Snowflake, Snowpark, and DBT make such a natural fit for building really scalable pipelines for data engineering. Then kick it back over to Prashant to go over some of the technical solution architecture and then how you would go about deploying a similar solution running on Snowpark Container Services, running Airflow within there to then manage and orchestrate your Snowflake pipelines. And so, Prashant, I'll let you into why Snowpark Container Services.
Yeah, cool. So maybe a quick raise of hands in terms of how many people have heard about or used container services in this audience? Okay, so looks like a few of you have already experienced container services, but just to recap what Snowpark Container Services is, the key benefit of Snowpark Container Services is you can bring in any language or any hardware with that flexibility and bring that inside of Snowflake security perimeter, right? So this can be like any language, like for example, R, C++, and you can use CPUs and GPUs inside of that, right? Second benefit of using container services is a unified services experience, right? Basically, you can effortlessly deploy and integrate image registry, elastic compute infrastructure, or Kubernetes cluster, right? So, and this session is about deploying Airflow and DBT. And then you can bring in any sophisticated data application, right? This data application can have a front end, back end, and so on and so forth, right? So as you can see, it's a very flexible environment to bring in any programming language, any type of compute running inside of Snowflake security perimeter, working on data inside of Snowflake, right? So that is the key benefit of Snowpark Container Services. If we go to the next slide, this session is about data engineering, right? So why Snowpark Container Services for data engineering pipelines? Number one is abstraction, right? So as data engineers, we love working with flexible data engineering tools. Almost every quarter or every 6 months, there would be an update of new cool data engineering tool that is launched. That tool, you can easily bring that into container services and start leveraging it, right? One of the examples is, of course, Airflow and DBT. Number two is maintenance, right? It's much more easier to maintain data engineering pipelines if you use container services by allowing the data to be used inside of Snowflake, right? And number three, and this is perhaps the most important part, you don't have to worry about setting up data security and so forth, because the data is already inside of Snowflake. You can reduce that data movement from your external systems if you were to deploy Airflow and DBT outside of Snowflake. The security benefit comes out of the box if you use SPCS for data engineering. Right, so these are the three key benefits, and I'll hand it over to George on why Airflow.
Yeah, thank you, Prashant. Appreciate that. And so, actually, a great question I want to kind of steal from you and ask is, who in the audience has heard of or used Airflow? Wow, okay, awesome. So, I won't spend too much time explaining kind of like the basics of Airflow, but if you're not aware, Airflow is a Python native open source tool to programmatically author, schedule, and orchestrate workflows. And so the beauty of Airflow, unlike traditional ETL tools, is instead of having to bring all your data into a tool, pay all these I/O tasks or all these I/O costs, and then also have to pay for the expensive compute of that ETL tool, Airflow is able to plug into your snowflakes, plug into tools like DBT and orchestrate those jobs using the compute of the actual Snowflake database, using the compute of Snowpark Container Services, while still giving you that abstraction layer so you can integrate Snowflake with the other tools that are within your data stack. And it's a tool that's came out in 2014, has only continued to grow. There's over 60 million monthly downloads, to over 2,000 contributors, over ton of GitHub stars, Slack, Unity. But what I really want to talk about here is how extensible it is and how you can layer it into your existing Snowflake environment to really get a lot more capability out of the tools you're already using through its rich scheduling APIs. And so why Airflow and Snowflake? So number one, Airflow is ultimately scalable. It's Kubernetes native. It runs on a scalable compute cluster, and it can dynamically scale to manage up to like hundreds of thousands of pipelines running at the same time. And Snowflake, as we all know in tandem, can scale compute almost infinitely in tandem, perfectly efficiently to achieve reliable data processing at scale without any performance degradation. So if you have a really powerful scalable scheduling engine and you have a really powerful actual compute engine, you can combine both of those to just create an ultra efficient data pipeline platform. And then secondly, because Airflow is Python native, and as anyone that's worked in ML can tell you, it's all very Python based. So having a Python native orchestration tool that can plug into your vector databases, can plug into every part of your ML stack, run your ML, use pandas, use simple things like NumPy, but also bring in like scikit-learn ML models, do your model training within Python, and have Airflow orchestrate it all just by wrapping it within a task wrap decorator. And then you can run those actual jobs using the cheap compute of Snowpark alongside your data. So instead of having to pay for the ton of I/O costs, because you have to bring out the vast streams of ML data, process them, then load the results back in your database. You're doing all that processing right next to your data. So you're paying way less in costs, but still getting really fast and efficient pipelines. And then because you have Airflow as kind of your overall monitoring system, you get pipelines that are easy to monitor and troubleshoot. And then finally, real-time analytics. Airflow can manage the continuous ingestion and processing of data, while Snowflake enables the immediate querying and analytics side of actually interacting with the data. So you can visualize it through tools like Streamlit. Sorry, almost escaped me. But it basically allowing you to have Airflow manage the continuous ingestion of this data, and then use Snowflake's kind of integration with all these different dashboarding tools to quickly visualize and surface this data to actual stakeholders, so you have true real-time data. And then bringing dbt into the mix further. So dbt is a really great way for structuring and managing and having kind of building blocks for interacting and manipulating your data. And Airflow, and something that my company Astronomer has actually come out with, which is Cosmos, which is an open source package that allows you to just copy and paste your dbt project, deposit it into your Airflow DAGs directory, and then have all those dbt projects, all those models automatically represented as tasks or task groups or as isolated DAGs within Airflow. Without needing to actually replicate all the bash commands to trigger them, Cosmos allows you to just immediately point it at where your dbt project lives, say, hey, if I only want to slice it to look at a certain model and only run these certain models, you can have that parameter just in a typical task definition, and then have all of that visualized within Airflow, and that gives you a whole suite of benefits. Number one, ability to manage your database connections in Airflow and then inject them into your dbt scripts, so making it really easy to switch between what Snowflake database you're using all through the Airflow connection system and not having to hard code it into your actual dbt project. You also have first-class dynamic dbt abstractions. If you've tried running dbt DAGs in Airflow without Cosmos, you'll notice that it won't even break up like a single model into the model and test stage. It'll just say, hey, we've triggered this model, and then that's it. If it's triggered successfully, then it moves on to the next task. Cosmos will wait and monitor that both steps of those jobs, break up the actual testing of the model, or the model training step, and then whatever the test step is after, into two separate tasks you can monitor and retry independently. And you also have a built-in virtual environment within Airflow to handle the dependencies. So if you need to bring in some kind of dbt or dependencies into your dbt workflows, you can include them alongside Airflow, have Airflow run that virtual environment in a self-contained system, and then leverage those dependencies to run your ML operations. And then also eliminates the need for other external CI tools just to independently manage dbt work, and you have full access to all your Airflow DAG parameters. You can actually parameterize your dbt workflows, have them triggered through the Airflow REST API, and then say, hey, I want to run this model in this database and trigger it just through a form. So we seem to completely abstract the running of their dbt models to where it's really just a form that someone's filling out, and then everything else is handled through those parameters being injected at runtime. And then having Snowflake being the underlying compute to power all of these transformations is just, it's a match made in heaven. You get a really efficient, really easy to use workflow scheduling tool, highly adaptable, and then you get a database that can power and manage all those transformations with no limitations. So hope that's given you kind of a good idea of why this is so important, why we're giving a talk on it. And now, hand it back to you for the technical concepts behind it all.
Thanks, George. So let's deep dive into like the different components of Snowpark Container Services, right? So if you look at this diagram on the left-hand side, you as an end user, right, you can build OCI compliant image using Docker, using clients like Docker or Podman and etc. Right? Then step number 2 is you can then interface with the built-in image registry inside of Snowflake and specify like a YAML file which has the specifications about your container, and leverage these interfaces in SQL or Snow CLI or Python API to create a compute pool. And within that compute pool, basically you have 3 different types of services or jobs that you can run, right? So number 1 is jobs, right? Which you can which you can create to manually trigger or structure a process like ML training, or maybe like running like a DBT job, right? Number 2 is service functions, which is more event triggered execution for time bound processes. And number 3 is services, which is like a web service which lives forever, right? So these are the 3 types of services and functions that you can create inside of container services. And yeah, all the egress and ingress to the container services is secured by default with right? So if you go to the next slide. Yeah, so when you're deploying Airflow and DBT on SPCS, this solution basically we do this in 3 steps, right? Number 1 is you deploy Airflow container on SPCS. Number 2 is then you deploy DBT container on SPCS. And number 3 is then you create like a job that is created on top of DBT on SPCS, right? So the Airflow is created as a service, right, which is a long-running service, right? And the DBT part is a job which is triggered whenever you want to trigger a event-based pipeline. If you go to the next page, yeah. So this is an example of creating an Airflow service. So this is as simple as writing few lines of SQL code. So create service. Name of the service, you specify a compute pool, right? This can be like set of like different CPU bound machines, and then where is it reading the specs from? You specify the specifications, what is the minimum and maximum instances, right? If you go to the next slide, this is a detailed example of how this service is created. So the name of the service, right? You specify a compute pool, right? And then you do the specifications. So when you're creating a service in container services, there's only 2 things to remember, right? One is you need a compute pool. You define it, right? Like minimum and maximum instances. And number 2 is specifications. And specification just contains the name of the name of the container, the image. Volume mounts is an interesting concept where you can specify where your DAGs are living inside of your stages, which are then mounted onto the container local file system, right? So in this example, in the blue dotted box, the source for the volume is @volumes, right? Which is a stage in Snowflake, right? And volume mounts, which is the line above that, is basically the local file system path for that container, right? So it is this stage and the DAG files that are uploaded there will be then mounted onto the container services file system, right? So very, very easy setup, right? You just need to create a compute pool and specify specifications, and that's all you need, right? So you will have airflow inside of container services. I don't know, George, do you want to add something here?
No, yeah, this is basically, it's just illustrating like, once you have your Airflow image, because everything's Dockerized, it's a relatively simple install. You're just pointing it at a Docker image volume that contains all your dependencies, your DBT project, everything, and then just installing it at Snowpark Container Services. And that's the beauty of both of those. You have a really easy way to install like just containerized Airflow, and Snowpark Container Services has an easy way to install where you're really just running this one-time script, and boom, you have Airflow running alongside your Snowflake data.
So this is giving you an example of the UI, how the UI looks like. So you will have the ingress served at port 8080. So when you do show endpoints, it will list down the endpoints, and you will have the ingress port as well as the ingress URL, which you can then like paste it in your web browser and access the Airflow UI from there. And then in terms of logging in, this is brokered through Snowflake Ingress OAuth, right? And once you log in, the Airflow UI is accessible. Right? So it's as simple as that. And then if you go to the next slide, now that we have Airflow set up, the step number 2 and 3 is basically to get DBT inside of container services. So, as previously mentioned, right, we are going to create a job on Snowpark Container Services to execute the DBT pipeline. If you go to the next slide, So in here, what we are going to do is to run DBT. We are going to use something called execute service, right? This will basically execute similar to like a task or a stored procedure inside of Snowflake. This is a similar concept where you're executing a job within Snowflake, and basically you specify the container, you specify the bash commands to run your DBT pipeline, right? So you can see DBT run pipelines dir and the environment variables, right? So again, super simple. You specify the compute pool and you specify a specification file, set up your environment variables, list down your images, and boom, you have DBT running inside of Snowpark containers.
Any questions, any comments?
So by running Airflow within Snowpark Container Services, do you still have to have it connect to an external database like Postgres for like the Airflow database, or is it using another Snowflake schema for like DAG runs and all that?
Yeah, so within this implementation, I believe this is spinning up a Postgres database just within Snowpark Container Services. However, the beauty of Airflow being modular is that you can swap that out for a Snowflake backend. So if you don't want to use the Postgres database, you can just leverage that Snowflake database that it's running alongside and just edit that configuration detail in the image before you install it. Awesome.
Hey, I saw you set up Airflow as a service, but then you were executing DBT service. So my initial impression was, wouldn't you just call DBT from Airflow?
Yeah, so you would be calling DBT from Airflow. So when you say call DBT from Airflow, what do you mean?
Like Airflow is used for orchestration, right? And DBT is for transformation.
Yeah.
So wouldn't you be just orchestrating DBT flows from Airflow, right? Why would you execute DBT as a service?
So yeah, you would be orchestrating those DBT workflows from Airflow. So we show these kind of two optionalities because you can install DBT as a separate entity, but what you could also do is install it as kind of a sub-entity within that Airflow Docker install. So the idea here was just show you two different options, but a lot of times you'll just install DBT alongside your Airflow container and orchestrate those jobs just totally through Airflow. So it reads the jobs, they're contained within your DAG directory, and then just we'll parse them at runtime and orchestrate them as Airflow DAGs.
And can you call Snowflake procedures directly from Airflow, or do you need something like DBT?
No, yeah, you can call it directly from Airflow. So that's where you can also use the Airflow connection details, inject them into your DBT models through Cosmos.
Hi, I just wanted to check that Kubernetes cluster that it's deployed on. Is that an external cluster?
No, that's running on Snowpark Container Services within your Snowflake environment.
You don't have to set anything up. You just do create service and it goes on there?
Yes, sir.
Yep.
Thank you.
No worries.
If you are using the metadata as a snowflakes, then it will continuously run the snowflakes. So that there is any cost thing increasing.
So you're saying like the cost of maintaining the metadata?
Yes, correct. In the snowflakes.
Yes, I mean, even in really heavy use cases, you're not going to be outputting more than like a couple gigabytes a month. So it's not really a significant cost basis.
And suppose any DAG is accessing some external API, can that is open for that one?
Wait, sorry, you mind repeating that question?
So if suppose any DAG is accessing external API, which is completely outside of the snowflakes.
Yeah, that's still possible. Yeah, that's still totally. So you can still access external services and connect with them from external services from Snowflake. Yeah.
So probably a basic question here. So what I understand is you're using Airflow for orchestration.
Yep.
And yesterday I learned there's also something called Snowflake tasks, which can do the same thing. So is there any advantage of using this setup over tasks?
Yeah, I mean, the beauty of Airflow really comes when you're integrating with other systems. So Snowflake tasks, if you're just living in a world like you're only doing Snowflake tasks, like good for you, just use Snowflake tasks. Where Airflow's value comes in, where you're not normally just using Snowflake within your data stack. You're connecting to, hey, I need to connect to these API endpoints and pull data from them and, maybe convert them to like, a CSV before I can actually upload them into Snowflake. Or, any number of use cases where data either has to leave or is coming from a service outside of Snowflake, that's where Airflow has a lot of value because you can use the Airflow connection management system. You have kind of a separate entity to actually manage the connections to all those services and visualize them versus Snowflake tasks is really good for managing Snowflake things, but you kind of have to ham it to like connect to other. You're basically doing a Python wrapper at that point if you're using it for like external services.
Hi. So I was wondering about the authentication layer that you showed. Is it like just a firewall where you get authenticated and then you are logged in as root in Airflow, or is it like a deeper integration where users get their own users on?
I'll leave that to you.
This is basically using the Snowflake OAuth credentials. So yeah.
Okay.
So this was a straightforward setup.
Okay. So you get logged in and then it's root in Airflow, right?
Yeah.
Okay.
Awesome. Thank you, sir.